to the Department of Energy's SBIR STTR Fiscal Year 14 Phase 1 Release 1 Topics webinar. My name is Chris O'Gwyn, and I will be moderating today's meeting. In just a moment, you'll hear directly from Manny Oliver, the Director of the DOE's SBIR STTR Programs Office. He will provide you with some basic topics information as it relates to this Release 1. Following Manny Oliver's introduction, you'll then hear directly from the subtopic managers, many of these subtopic managers for topics 1 through 15, as they clarify their expectations and answer your questions regarding their specific subtopics. And many of the questions received during the registration will be addressed as well. I will tell you up front, we've had with topics 7 and 9, we will not be presenting those. So if you do have questions on topics 7 and 9, please email directly to those topic managers, as they will be identified on the slides as we go through that, or you can find the topics document on the DOE SBIR STTR website, and you will find that the address for that, the web link throughout the webinar. And a couple other things. Yes, you will receive a web link to this recorded webinar following the webinar. So if you're hearing me right now, that means you're registered, and all registered participants will receive that link directly from us following this webinar. It will also be available on our website as well. And I believe that's about it for the housekeeping. So let me go ahead and turn this on over to Manny Oliver as he gives you a brief introduction here to where we are. Thank you very much.
Again, just the brief agenda, as Chris mentioned, I'll just give a 5-minute introduction. And again, today we're just introducing the topics. Many of you might have questions about the number of awards and issues that would, questions we can address better when we put out the funding opportunity announcement, which will be occur in August. But today we're just really focused on the topics and your technical questions related to the topic areas. And again, we have 2 programs represented today in topics 1 through 15, the Office of Advanced Scientific Computing Research and the Office of Basic Energy Sciences. And we do have webinars on Tuesday and Wednesday for the remaining topics. Next. So for fiscal 2014, there are 2 Phase 1 announcements. We refer to them as releases. So Release 1, and here is the list of the programs participating in Release 1 and Release 2. And Release 2 will come out later in the year, about 3 months from now. So with Release 1, indicate these are going to be 5 of the programs from the Office of Science, as well as the Office of Defense Nuclear Nonproliferation. In Release 2, we will have many of the applied programs. One of the changes we made this year is that the Office of Fusion Energy Sciences, which last year participated in Release 1, has moved over to Release 2 this year. So please be aware of that for some of the folks who are expecting to see fusion energy topics in this release. There will not be any, but they will be in Release 2. Next slide. And again, here's our Phase 1 schedule for the year. And for both Release 1 and Release 2. There's not much that's changed. It's very similar to the schedule for last year. Just want to, for those of you new to the program, we do release the topics about a month before the funding opportunity announcement. We do have a letter of intent requirement, and that's a mandatory letter of intent. So please be aware of that. And again, there we're just looking for an abstract from your for your full application. For this Release 1, the applications will be due October 15th. And you can expect to hear from us in early January as to whether you were recommended for award. And your grant would start in February. Next. When we issue the funding opportunity announcement, we will hold a webinar later that week. The FOA will come out on Monday, and on Friday we'll have a webinar. And that's your opportunity to ask questions about, how do I apply, and questions more in the mechanics of the application. As I mentioned, today will be mostly focused on questions about our topic areas. And there will be plenty of opportunity for Q&A there as well. So, and getting into the topics, the questions we get around the topics, where do we get our topics? So the topics are created by DOE program managers. They are often funding R&D, not only at small businesses through the SBIR program, but through universities and national labs. They're very up to speed on the activities in these areas. Many of them cover a fairly broad area, so they do rely on other experts, sometimes in the national labs and in industry and universities, to formulate where the breakthroughs needed to move some of these technologies forward. The other thing is, when we put out our topics, we do organize them by the program office. If you're new to DOE, probably over time you'll learn which program offices fund which types of research that might be of interest to you. What we do in our topics is list the DOE program managers associated with each topic and subtopic. You are allowed to ask them questions at webinars like today, but you can certainly email them between now and the time you submit your application. We do want to point out that their role is really to clarify what they're looking for, what the topic is about. It's really up to you to decide to apply. So you really shouldn't be asking them, should I apply or not? That's really your decision based on finding whether the technology and the expertise you have is a good fit to the problems they've identified in their topic. Next. Sorry, this is a little compressed on the right, but this is an example of the topic. So each of our topics is numbered, and each of our subtopics has a letter. Those are very important, so you need to specify the topic and subtopic when you submit your letter of intent in your application. If you submit an application, for example, without a topic and subtopic, we won't try to assign it for you. You will just be administratively declined, so do pay attention to that. We have added a new header this year. It's a little box in blue up above, and that indicates the amount of the Phase 1 award and the Phase 2 award when you submit for Phase 2, and also indicates whether we're accepting both SBIR and STTR applications as well as fast-track applications. So do read through that header for each of the topics you're thinking of applying to. As I mentioned before, we do list a program manager. They may vary by subtopic, so do make sure when you're asking questions that you pay attention to the fact that there may be multiple managers associated with a single topic. We do have another subtopic. Sometimes we get questions about that. Again, the purpose of that is to allow you to submit things that clearly fall within the topic. So again, at the top of this, beginning of topic 7 here, there's a broad description. It must fall within that broad description, but it might fall outside of the specific subtopics A and B here. And in the past few years, about I think 6 to 9% of our awards have gone through the other subtopic. And again, many but not all of our topics provide references. So these are provided by the program managers to help you bring you up to speed about what's going on in these fields. So we encourage you to take advantage of those. Next. One of the things we introduced last year were technology transfer opportunities, and we're going to continue that this year. These are really an opportunity for you to take advantage of intellectual property that was developed either at a DOE lab or university. And the intent here is different from our regular topics. In our regular topic, you are the program managers have identified a breakthrough that's required, and you're going to come up with an idea to address it. Here we've identifying, again, the intellectual property, something that's usually been patented or has a patent application, and we're looking for you to take that invention and drive it towards commercialization. So not only do you get an SBIR or an STTR grant, you would also get an option to license the technology. There's more details of this in pages 1 to 2 of the topic document, so we encourage you to look at the very beginning of the topic document if you're planning to apply to a tech transfer opportunity. And again, these tech transfer opportunities will look a little different in the sense that you'll see much more information related to a national lab or a university. So we will provide you with contact information to a tech transfer office at a national lab. And any questions you have about the status of patents, the state of the technology that was developed in the lab, how far they went, are there any research reports, you should direct those to the national lab. If you have any questions about what is the DOE program interested in seeing you do with the tech transfer opportunity, you can direct those to the DOE program manager that's also listed there. Next, we have our last slide. And this just relates to fast-track applications. Again, this is something we introduced last year. It's a combined Phase 1, Phase 2 application. And the purpose of this is to eliminate the gap When your phase 1 ends, you apply for phase 2 and you secure the phase 2 funding. There's typically about a 5-month gap at DOE. Submitting a fast track application would allow you to avoid that gap. I would caution you that it's certainly much more challenging to submit the combined application. You do have to submit the full commercialization plan that's required for a phase 2 application. So it may not be suitable for majority of our applicants, particularly people doing very high-risk work in phase 1, where the phase 2 work is not really well defined or hard to define at this time. For last year, only about 4% of our applications were received in fast track, and we expect it to be, to stay below about 10%, that this will be a minority of the applications received. I would point out that our fast track award rate last year was similar to that for our phase 1 award rate. I think that's our last slide. Just point out, again, I think these slides and a recording of this webinar will be made available in case you missed or want to go back to any of the slides here, such as the contact information for our office. I think from here we'll go through and again cover the topics and take your questions and address some of the questions that were submitted today, submitted prior to the webinar. So I'll turn it back to Chris.
Yes, and let me just point out that you may text your questions via the chat text box as they relate to each of these topics during the topic discussion, and we will present those as appropriate to the topic manager as he or she finishes up all of the subtopics underneath that one subtopic. Please keep in mind that this is a topics webinar, so if you're submitting questions in regards to the funding opportunity announcement or eligibility as a small business or something about the PI, please direct those just to our office at any time, and more specifically, we will, as Manny mentioned earlier, we'll be putting out a funding opportunity announcement next month, and we will also be having shortly thereafter a funding opportunities announcement webinar, and we'll be able to answer your questions more appropriately at that time. So if you have a question in regards to the topic, specifically its subtopics, you may submit those during the manager's presentation, and then we will present those as appropriate following his or her discussion. So let's go ahead and kick off with Topic 1 from our Advanced Scientific and Computing Research program. And Topic 1 will be covered by Rich Carlson. Rich?
Thank you, Chris. The Oscar Advanced Scientific Computing Research Program Office has two main components. One is a facilities division, which has 3 large supercomputers and an IP network to cover the U.S. backbone to supply networking activity to the science communities that use our facilities and allow access to other facilities both nationally and internationally. We also have a research program that deals with applied math, computer science, specifically trying to build a next generation supercomputer, the networking program, and a computational science program to link the computer science research with the domain science communities. Our SBIR program focuses on 2 major topics. One is the advanced networking technologies and services. There are 3 subtopics in here. One is management tools. We know that IP networks are used throughout the globe for people doing science and for other communications. And we find that those networks are relatively hard to manage. There are a lot of tools that were either homegrown or people use things that were created by some open source community, and there's usually little support or ad hoc support, and we'd like to see that improve. So we're looking for people to send us proposals to deal with how do we manage these kinds of networks, either in a regional network, a campus network, a DOE network, a state network. We don't really care where those networks are used because it's all the same network technologies, but we'd like to see them used and better managed so it's easier for people to understand what's going on in the networks, both the user community and the operator community. The next topic is optical networking. Optical networks have revolutionized the way we do things in the wide area. They're moving down into the commercial world in regional and to the home. We also see optical networking moving down inside the computer, replacing copper wires with fiber optic communications. And so we're looking for component services, tools that allow you to build or manage these kinds of networks and these kind of components for networks that allow us to do a better job. The third topic is middleware and networking is data aware. DOE and its science communities generate a large amount of data. Moving that data, storing that data, dealing with the workflow management systems, being able to do science with that data is a very important element. And we have a lot of work that's been done in the past in that area. And what we're looking for is people to either harden the technologies and tools that we have already developed, or to come up with a compatible version or a comparable version that allows people to deal with science communities and other user communities to deal with this large amount of data that is floating around or being generated on servers and systems today. There is a technology transfer opportunity dealing with cybersecurity, and that's run out of the Oak Ridge National Laboratory, and the contact information is there. Next slide, please. The second topic is high-performance computing. We're trying to push high-performance computing out of the realm of pure science and into the realm of advanced manufacturing and engineering. We think that high-performance computing can have a huge impact on the ability of a small company to develop a new product, to prototype a product in software rather than bending a piece of metal first, or to change the way they do business. And so we're looking at services and solutions that do this, and there's three major elements. One is a complete turnkey solution that you can put forward, and someone could stand up and run your application, your code, with the ability for them to do a job. So the idea is that they don't have to become an expert in using your code. They become an expert in the manufacturing and engineering tasks that they are interested in doing. We know there's a lot of tools that have been built in the past and other services that are required. We see the cloud computing environment moving forward, and so we would like to see tools that make it easy for engineering and manufacturing communities to start using compute resources either that they own or that they purchase on a as-needed basis. And then lastly, there's a lot of code that has been developed for science use that could be beneficial for industry as well. So we'd like to see that code hardened. We know that a research piece of code may be usable by the developer, but that doesn't mean that the user community, manufacturing community can use it. So we'd like to either see our codes hardened, or if you have a comparable version of code that does the same thing, then you could push forward that and say, we'd like to make this much easier to use by the science communities, or by the manufacturing and engineering communities that we want to see benefit from this code. Those are the two major programs inside OSCAR, and I'll entertain any questions that might come up.
It looks, Rich, it looks like we have one question that came up. It says, regarding optical network support services, would that include higher risk work, such as the development of on-chip optical sources for optical interconnects?
Yes, that is something that we have looked at in the past and will continue to look at.
Okay, well, very good, Rich. I think that's all we have for now. Why don't we go ahead and move on to to topic number 3, and that would be covered by Eliane. Eliane, the floor is yours.
So the scientific user facilities promotes research and development towards the present, the current, and future facilities that include neutron sources, X-ray sources, and the FEL lasers facilities. For this year, we have chosen 2 main topics, which are detector technology, R&D, and X-ray optics, R&D. Within this tool, we ask the experts what are the main areas that should be addressed. We are looking for above state-of-the-art instrumentation that allows for detectors the enormous use of data that is coming from the experiments. We want a higher accuracy, spatial definition, energy definition, and for X-ray optics, we realize that there has been a need for attention to the area, and we have asked for also breakthroughs from the state-of-the-art. Within the detectors, we have subtopics like high quantum efficiency area, vacuum, infrared, and so on. And we have also 3 topics within X-ray optics. Many references are given. I call attention for the detectors for the results of a recent workshop that was done, sponsored by BES, and you can access it through the SEC, the Office of Science website. It contains the main research priorities direction, and the topic was very much based on the recommendations by the experts in the workshop. And the same thing for X-ray optics. We base the selection of topics on the recent workshop and the recommendations by those experts.
All right. Did you get any questions in advance for this?
I did some questions. Yes, I did get some questions in advance. I have to say that many of them do not refer to my topics. Questions are asking about energy efficiency, funding available for Phase 1 SBR, are types of questions that I am not able
Did you get any
to answer.
very specific questions?
I have one specific question asking about materials for detectors, and I have to say that is part of the research that the proposer has to do. He has to look for the type of detector that he wants to offer a breakthrough and select the type of material that he feels is the most appropriate for that detector. That was the most specific.
Okay. Chris, did you have some more?
There's one question in regards to your topic 3A. Are you able to elaborate on what detectors currently are in use there?
What do you mean?
And if not, maybe we can have them contact you directly?
He can. I can direct him to the workshop report that specifies things that are being done today and the things that are being sought for future applications. Types of detectors used today, they are some superconducting detectors. There are scintillators. There are PADs. There are several. I would recommend looking into the detector workshop report and having a complete list of available detectors and future directions for detector development.
Would that be one of the? Would that be included in the references underneath this topic, Eliane?
Yes.
Very good. Well, then we can point them right to the references for topic 3A here. And then if there's no other questions for topic 3, let's go ahead on and move to topic 4. And this is still Eliane, optics devices for light source facilities.
Yes. Again, I didn't get, at least on the questions that were forwarded to me, no one specific towards X-ray optics. Many of the questions are related to energy conservation that are not under my age.
Okay, that's fine. Yeah, you did have another question that came in online. It wasn't related to topics 3 and 4, but I think related to the topics you've sponsored in the past, and said, can you give some background information about why there are no accelerator-related topics in this year's BES topics?
Yes. The topics related to accelerator were available for more than 4 years. We have had quite a wide variety and very deep response to those topics. We have funded many projects, and the community pointed out that the 2 topics that needed really serious attention were instrumentations, among them detectors and X-ray optics. And we decided then to fully concentrate on those 2.
Thank you.
Well, very good. And again, if anyone has any other questions as it relates to topics 3 and 4, they can submit those directly to the email address that you see on your screen right there. And Manny, I don't see any other questions coming in for this topic. Are we ready to move on?
There's a question under you got chat questions. There's one question.
Oh, you mean the hand raised?
Yeah.
Yeah, I think somebody had.
It says chat questions 1 and answered.
Oh, yeah, I think that's the.
Yeah, that's just our screen there.
Sorting.
We've pulled up all the questions that we've had. That was a flagged question there that you already answered.
Oh, yes. Salim Bush, I know him very well, and I can understand why he is asking that.
All right. So
there are no accelerator-related stuff this time.
Okay, let's go ahead and move on to topic 5.
Jane.
And Jane?
Jane's not here. Is she online? She's not here in the...
Okay. So we do not have Jane. Jane Zhu will be calling in or dropping by shortly. So why don't we just go ahead on off to topic 6. I believe Elian, or Thiaga, is going to cover this. Am I correct?
Hi. I'm going to move closer. Yeah, right here. So we have a core program on the neutron scattering technologies, for mostly pushing, our core program actually has to push the technologies for future needs of the scientific research. So the needs are very high resolution, both spatial and temporal resolution neutron scattering detectors. These are needed in the sense, for the case of like spallation neutron source, we need to do both neutron scattering, diffraction, imaging, all kinds of things, and always there is a need for higher resolution and higher temporal resolution. Also, high efficiency detectors. So, as you all know, helium-3 is not anymore available, but helium-3 detectors themselves are not. They're efficient, but they don't have the spatial resolution that we need. So, alternate technologies are needed, and that's why we have been having this program for a longer term, trying to see what small businesses can offer in developing these kind of technologies. The other topic is the need is neutron optics. So neutron optics, we have guides, we have lenses, all those things, but neutron scattering always suffers from the very low brightness of the source. So in specific cases, some of the experiments cannot be even done. So focusing optics become important, and also any kind of focusing optics that's novel, that can be used for a wide bandwidth. The neutron sources like spallation neutron source will be very useful in the sense it can actually increase the rate, and also it can lend doing experiments. So that's another topic. And the third topic is, we need a very special sample environment. Sometimes they can be very complicated and exotic in some cases. So we really would like you to find out what kind of things are done and what could you develop. So these are the three topics, major topics that we would like to cover under this program. And the references are there for you to really go through and find out what's the state of the art. And also, I think it's easy to access, the websites of the user facilities like SNS, high-flux neutron, isotope research reactor, and then also at Los Alamos spallation neutron source. In addition, of course, there is also a reactor at NIST. So you can, if by going over to their websites, you can actually get a knowledge about what are the things that are there, and by talking to the instrument scientists, especially, you can find out what the needs are. So those are the topics that will be sort of will be needed from SBIR route. And new research leading to detector and all these technologies. So I got about four questions.
Are you, Thiago, are you able to address what is the time resolution needed, or what is the spatial resolution needed as it relates to 6A, topic 6A?
Yeah, the spatial resolution depends, so I don't want to give one number. There is nothing like one number. It is it varies from technique to technique. For instance, from diffraction to move on to inelastic scattering to imaging, it can vary. So I think if you are developing something for a certain class of experiments, you cannot just do one detector is not going to cover everything, every application. Right. So you got to really focus. Okay, what is your strength, and then what is up there in that kind of realm, and then you got to go after that. So there is no one number that I can give you. So it also has to have these not only the spatial, temporal, and also efficiency. All these three things should go together for a class of experiments.
And what about in regards to the other subtopic? Is there a need for cost-effective electronic readout systems to read out detectors?
Yeah, because that's a part of it, right? Once you develop something, the detectors have to be, like for instance, if you are doing experiments that are the instruments at the spallation neutron source, in addition to XY, the position, you also need a time stamped. So the faster electronics are needed for that. So you really need, and a detector is actually, in addition to that, there's electronics, integrated electronics. That, of course, can be easily adapted in the facility. So talking to the facilities is extremely important for your success.
Very good. Very good. And I believe that was the last of our questions for topic 6.
Yeah, I had some questions submitted in advance, Chris, so I think it was
okay.
Yeah, I think if somebody asks scope and basic requirements, I think it's all there. The topics are very specifically defined, so they have to look at those descriptions. And what is the desired spatial resolution? I already addressed. Limitations for the use of government facilities. Boris has had a question. I don't know what it actually means. Boris, are you there?
Yeah, again, they're all muted. So.
Oh, I see. So limitations, I don't know what it means, but my understanding is, can you do your research at, let's say, NIST, for instance? Of course you can. But the thing is, the end of the day, what we are looking for is these technologies for our DOE facilities. That's the mission. And then what we are using a specialized sample environment for development of new pharmaceuticals. And neutron scattering. Okay, so pharmaceuticals is not our mission. Our mission is materials research, phenomena, things like that. So pharmaceuticals is not in our mission. Can small companies apply in collaboration with the national lab? Of course, that's the SBIR question. Further questions you need to talk to, contact SBIR for clarifications.
Yeah. So again, that certainly is the case both under SBIR and STTR. Those type of collaborations are certainly encouraged.
Is there any other questions? I don't see any questions. So I'm done.
Okay. And I believe Jane will be joining us shortly.
I'm here.
I'm
here.
So then why don't we go?
The were not very topic specific earlier.
Okay. So you could just.
Okay, so this is topic 5. This is in regards to instrumentation for electron microscopy and scanning probe microscopy. Jane, the floor is yours.
Yes. Yes. Oh, I didn't bring the. You want me to?
Just a brief introduction. What you're looking for.
Oh, okay. We're looking for capabilities. I mean, the significant improvement capabilities in electron microscopy. Electron microscopy mainly on transmission electron microscopy. And energy resolution, I mean the spectroscopy. The scanning probe, again, it has to be much much more improved than the current capability, and we're addressing materials research area.
That's fine. Yeah, I think we're just most of the details are in the topics. We're not really looking for our topic managers to really repeat their details, but again, just to give you a brief description of what we're looking for. And again, we're fielding questions from anybody who wants to type them into the chat by chat. Again, we're not doing for those of you trying to raise your hand, we're doing most of the question submission through the chat box. So. Okay, so we did receive a question in. It's rather lengthy. I'll go ahead and read it out for the audience. In the program announcement, it mentioned about DOE interest in insulated and shielded probes and electrochemical cells for high-resolution electrical imaging in conductive, I guess that's materials. I see in the last year there was a company receiving an award for developing probes for conductive AFM under liquid. Are you still interested in such probes? And can we submit a proposal for developing probes for conductive AFM in liquid media?
I think the answer in general is yes. It's a competition. So whoever provides the best capability will be selected.
The next one is, will DOE be interested in an array-type electron source?
No. It has to be a point source like we use in the transmission electron microscope. We're not interested in arrays.
Okay, I think there are no other questions, so Chris will.
Yes,
Jane.
Okay, thank you.
Thank you, Jane. We'll go ahead and move on to topic 8. As I'd mentioned earlier, there's topic 7. Larry Ron will not be joining us, so if you have any questions as it relates to any of these subtopics here in topic 7, go ahead and contact Larry Ron directly via his email address there. So I believe we'll go ahead and move on to topic 8, which would be Mike Casasa. Mike, you there?
Yeah, hello. This is Michael Casasa. Okay, this topic is about instrumentation for ultrafast X-ray science. Now, you may have seen in the previous topics the words ultrafast and the words X-rays, but this is the topic that combines the two. In BES, we're very interested in probing the fundamental chemical transformations at an atomic or molecular level. And increasingly, it appears that a good way to do this is with X-rays. Typically, X-rays will be, I hesitate to offer a wavelength range, but they correspond to transitions amongst electrons in the inner shells of atoms. These are not hard X-rays necessarily. And those reveal chemical information about their targets. And with ultrafast pulses that are picosecond or less, maybe in the range of femtoseconds, you have time resolution to see the particles in a molecule actually adjusting positions. So that's what we're after. That's what we want to be able to do. There are many examples of, I would say, demonstration of production of short X-rays in the literature. This is really cutting-edge science at this point. All of these have an allusion to their applicability to probing chemical systems, but the actual numbers of applications out there are very few. And we're looking for SBIR projects that will take some of these approaches that we've seen in the laboratory and render them more useful, more generally useful for investigating chemical systems. So the subtopic, as I've written it, is really broad. It includes developing directly X-ray sources, but also more indirectly developing laser technology that's used as in a step along the way to generate X-rays. For instance, there are people producing X-rays starting with near-infrared lasers. It turns out the physics of the high harmonic generation process that it relies upon may work better with longer wavelength lasers. So we're interested in that development. That's just one example of X-ray development. There's plenty of others. We're also interested in ideas for how to synchronize these ultra-short pulses with other aspects of an experiment, and how to characterize those pulses. That's all a challenge. I've given you some historical references in the subtopic write-up. Those are still pretty good. For finding out what's really current, what's really happening now, I would highly recommend that you go look at the abstracts for recent physics conferences, particularly the American Institute of Physics, or the American Physical Society's Division of Atomic and Molecular and Optical Physics. There you will see most of the practitioners doing fundamental research in this area. I think that's all I need to say for now.
Thanks, Michael. And Manny, I don't see a question for topic 8 here at the moment, so unless you see something we can move.
I had one question that came in email that was really general, and I didn't know the answer to it. It was about whether there was a set-aside for the Fast Track Awards.
Okay. All right. And again, we'll address those FOA-type questions or funding opportunity announcement questions in our next webinar. But again, today we'll just focus on the technical topics.
Okay. So we'll move on. And as I mentioned earlier, topics 7 and 9 will not have any representation today. But if you have a question for topic 9 here or 7, you can refer directly to our topics document, and you can contact these topic managers directly. Topic 9 here for software infrastructure for web-enabled chemical physics simulations is Mark Peterson. So I believe we have online here for topic, let's see, we have some questions coming in, but they're related to some future topics. So let's go ahead and continue on to topic 10. That is a technology transfer, a TTO, technology transfer opportunities topic. And you will see under A and B subtopics the contacts for those, the laboratory contacts, so you can contact them directly. And as we move on here to our topic 11, wide bandgap semiconductors for energy efficiency and renewable energy, I believe we have Marina on the line. Marina, are you there?
Yes, I'm here.
So the floor is yours, Marina. All
right. So wide bandgap semiconductors are semiconductor materials with band gaps significantly greater than 1.7 electron volt. And for this reason, they offer the opportunity for dramatic performance and efficiency improvements in a wide variety of applications. Compared to today's silicon-based technologies, they have the advantage that they can withstand greater voltages over time, switch at higher frequencies with lower power losses, and operate at higher ambient temperatures without external cooling. The wide bandgap semiconductors for energy efficiency and renewable energy SBIR topic is focused on solid-state devices employing wide bandgap for use in power electronics per the overall topic description. More specifically, this topic addresses the significant improvements in device reliability that are needed for widespread adoption in critical energy-relevant lower power markets. These applications, which are of interest and meet the needs of the ERE technology offices, include 50 to 150 watt external power supplies for consumer electronics and appliances, electric drive vehicles, medium voltage motor controls, and grid power conversion. More information on the wide bandgap interests for power electronics within ERE can be found on the ERE Advanced Manufacturing Office website, including a summary report of a workshop that we convened in July 2012. For this solicitation, we have two specific subtopics, A and B, which I'll briefly speak about shortly. Both are pretty well defined in their descriptions and address fundamental reliability concerns and the identification of failure and degradation mechanisms for wide bandgap power devices. In particular, for both, they're targeting silicon carbide MOSFETs. To address a common question that's been received and elaborate on the definition of other areas in subtopic C, grant applications that fall within the scope of the topic description will include proposals that address other fundamental device reliability, degradation, and failure modes, as well as associated barriers for wide bandgap-based power transistors, whose solving can assist manufacturers in the commercialization and wider spread adoption of the above-mentioned power electronics applications. So this could include, for example, gallium nitride-based transistors or other device reliability, degradation, and failure concerns that are blocking their scale-up in manufacturing. For subtopic A, the purpose is to fundamentally understand the failure mechanism of commercially available silicon carbide power MOSFETs, which are caused by a large density of interface and bulk traps present in thermally grown gate oxide films, as well as other defects present in the epi layers of silicon carbide, such as threshold voltage shift under application of gate voltage at elevated temperatures. The outcome of these experimental results should result in a fundamental understanding of this reliability concern to help guide manufacturers to solve these issues. For subtopic B, the intent is to increase the ruggedness and address performance degradation and power device failure of silicon carbide MOSFETs that are caused by cosmic rays through the identification of failure modes and the conditions that initiate them. Cosmic ray-induced effects exist not only in space and high-altitude conditions, but terrestrial ones as well, and these can strongly influence the voltage derating necessary for the safe and long-term use of power devices. Proposals will need to establish and compare the influence of cosmic radiation on silicon carbide MOSFETs and silicon IGBTs under conditions in regards to cosmic radiation events. These effects will need to be analyzed to determine the long-term reliability and performance of these technologies. Through these results, designers will be able to make better choices in the use of either traditional silicon or wide bandgap semiconductor, specifically in this case, silicon carbide, for different applications. Finally, to address another key question that was submitted, the primary focus of both subtopics A and B is experimental in nature. So while including modeling approaches might be necessary and acceptable, the majority of the effort should target experimental approaches as described within the subtopic descriptions. Experimental testing, as described, is particularly important to ensure that the results provide actual and accurate data of the degradation and failure mechanisms of actual tested devices to make the results most beneficial for being able to properly solve these issues by manufacturers. I think that's it, unless there are other questions.
I think there were a couple questions there, Marina. Let's see. Can you give the specificity, or given the specificity of topic 11B, are hardware deliverables desired or expected in phase one of this topic? And I'll just point out that we're not looking for any deliverables in any of our topics and subtopics in regards to what is being sought. There is a final report that will be due, or interim report that will be due following either a phase one or phase two work, but we're not looking for any deliverables. But maybe you can address it from that perspective, Marina.
Yeah, I mean, I think my answer would be very much in line with the one that you just provided, and not, we're not looking for any specific hardware deliverables. More in terms of fundamental understanding and data and results that can, experimental results that can show what's really going on within these devices, within the materials that's hampering their performance and their long-term use.
Very good. What about do gallium nitride power transistors fall within 11C with the other
Yes.
subtopic?
Yeah, so I actually answered that within the description that for subtopic C, gallium nitride-based power transistors would perfectly be acceptable. Really looking at the overall description and generalizing the first two subtopics, which are fairly specific. They're both geared towards device reliability, failure and degradation mechanisms, and wide bandgap power devices. So gallium nitride would certainly fall within that scope for subtopic C.
So I apologize if you answered this as well. I'm trying to pull these questions together here. For topic 11C, will metal oxide wide bandgap such as zinc oxide or other metal oxides be of interest if a figure of merit for power electronics approaches or exceeds that of silicon?
Yeah, so zinc oxide can be perfectly acceptable if these are actually at the device stage and not at just the pure substrate or thin film stage. So if there are failure mechanisms that have been identified within thin film or bulk form metal oxide based devices, power devices, then those also could fall within subtopic C.
Okay. Manny, did you have something?
No. Again, we are getting a number of questions. I think we can answer a few more, but some of those may have to wait until, may have to contact Marina directly by email.
Okay. Let's go ahead and take one more question here from Marina. This is for topic 11B. Is there an experimental measurement desired in phase 1?
There's a description within the topic of several of the typical testing methods that could be employed. And so from there, it is up to the proposer to develop and propose experimentation using one of those testing methods.
Okay. Well, very good. Well, thank you very much, Marie.
Okay. Yeah, let's go ahead and take another one. I think there are some questions related to, one is, are you looking for novel MOSFET constructs? Another, will you be interested in novel concepts that may mitigate concerns through their bulk construction and operation of power devices? That second one relates to A, B, and C.
Those could potentially fall into subtopic C. However, I also want to make note that we do also have other funding opportunities and efforts within EARE as well as ARPA-E that address the actual fabrication and development of novel MOSFET designs. And those types of proposals would be better suited within those funding solicitations because that's really the intent of those efforts. Within this effort, we're looking at addressing degradation, reliability effects on these existing developed device designs.
Okay, thanks. Marina.
Thank you.
So moving on to topic 12, catalysis. We have several subtopic authors here, managers. Let's see. I believe we have. Who do we have online here for topic subtopic A? Jacob. I see Jacob online here.
Yeah, so is this the non-PGM catalysis one?
No, well, Gene Peterson, we have you, Gene, and Brian that will be addressing all 4 to 5 of these topics here. So Jacob, why don't you go ahead and start then if you want to jump right. Can you give a general overview of what the catalysis topic is? And then you can talk about your subtopic D.
Oh, okay. Yeah, well, I'm only covering the subtopic D part. I'm not sure about the rest of the topic, so I'll just jump right to that, if that's okay. Yeah, so subtopic D is about development of new non-PGM catalysts for the oxygen reduction and oxygen evolution reactions for low-temperature fuel cells and for reversible fuel cells, which would include acidic polymer electrolyte membrane fuel cells and also alkaline membrane fuel cells. And we're also considering catalysts for the hydrogen oxidation reaction, but that's only for alkaline membrane fuel cells, not interested in acidic fuel cells for hydrogen oxidation. So that's the gist of the topic. So in particular, we're interested in catalysts that demonstrate activity meeting the DOE targets, which are 300 amps per square centimeter at 0.8 volts. And to meet this target, both high catalytic activity, and also good mass transport properties are needed, but there's more of an interest in the catalytic activity at this stage. And we did receive a few questions about this subtopic. One of them was a question of whether we would consider greatly reduced PGM catalysts or only completely PGM-free catalysts. For this subtopic, we are only looking at completely PGM-free catalysts. We already have a portfolio of projects that include PGM catalysts, and we're not looking to add to that at this time. So that's only I'm only speaking for subtopic 12D. I can't speak for the rest of the topic. I'm not sure about that. We also got a question which is a little bit more general, which is how important is a support letter? I'm not sure how specific this is to this subtopic, but I guess I would just say that we certainly take support letters into consideration, but the most important factor is just the technical merit of the proposal. And that's all I have about 12D.
Okay, very good. And it looks like that's about all we're going to have here on topic 12 for catalysis. You can see who the topic authors are. Gene Peterson for subtopics A, B, C, and F, and Jacob Spendlow for subtopic D. You just heard from him. And then subtopic E, you can reach Brian Valentine at that email address there. So if you have any questions, please email those managers directly. And no other questions that are coming in specifically for D at the moment that can be answered. So why don't we go ahead and move on to topic 13, which would be membranes and materials for energy efficiency. And I believe we have online here, we might have Will James.
Yes. So I'm going to speak on behalf of topics 13B, which is innovative durable materials for extreme use conditions, and then also speaking on 13D, which is the other category. The technology manager is going to be responsible for that would be Erica Sutherland, but I'm going to speak on her behalf for this particular subjects. So right now what we're looking for is we've identified a gap in the deployment of hydrogen fueling stations where we need to look at polymer materials in extreme environmental conditions. And these extreme environmental conditions obviously involve hydrogen, but also high pressures, anywhere up to 100 megapascals or close to 1,000 bar. And variable temperature range from low temperature in the minus 50 degrees C range up until 200 degrees C. And with these technologies, we're looking to make them lighter weight and cost effective. And so a lot of the commercial applications involve the use of polymers and composites. And we're trying to understand in more detail how the materials behave in these extreme conditions. And some of the information we're looking for is hydrogen uptake, degradation mechanisms where possible, and then trying to extend the service life of these. In some cases, for instance, with the use of hoses or seals, we're having to change these out only after about a third of their target service life. So improvement in those areas, as well as just gaining a fundamental understanding of the material's behavior is what we're looking for. Other than that, most of the questions that I received for topic 13B, there really wasn't anything from the questions standpoint. It is a kind of a new topic area for us. And anything else related to components or hydrogen production or delivery would be submitted under 13D. And so that's all I have.
Okay, very good. And I think we're going to have in for, we have Ed Petro. Are you there?
I am indeed. This is Ed Petro, helping Jim
Ed
Broderick.
Petro. Thanks.
I want to talk just for a moment about the organic light-emitting diode portion of the solid-state lighting activity at DOE. For those of you who may be new to this program area, I encourage you to go to the Universal Resource Locator listed in topic 13C for a wealth of background information and reports. The most important element of those reports is our multi-year program plan, which establishes performance guidelines and some cost information for where we need to be with OLEDs in order to make a significant market penetration. Derived from that roadmap are these two highlighted areas for research, which are the subject of this solicitation. The first one is in novel materials, and the second is in novel methods of manufacturing. These are both very broad, and they were intentionally kept broad to encourage a wide range of responses from various people who may be working in other areas of electronic organic materials research that may find applicability in solid-state lighting. So we have received a few questions. Several of them were very specific about a particular technology. For those that are very specific, I would encourage the authors to correspond directly to Jim Broderick, whose address is shown on the website, or on the view graph and in the FOA, and he'll make sure that you get an appropriate response from a cognizant person. More generally, however, people were asking if quantitative data would be needed or some sort of proof of principle would be required. And that really is not essential. What we're looking for is some technical input that would encourage us to say yes to a specific proposal. So I would encourage any author who's thinking about submitting something that hasn't been proven experimentally to look at theoretical prediction to try to bracket the performance expected and put that in the context of the multi-year program plan. That's about all I had.
Well, very good, Ed. We do have a question here, I believe, for 13B. Let me read this. This is for 13B. Can the research look at scale-up of these TBC coatings? We are looking to do the technology transfer and partnering with a university. That might be for you, Will,
yes.
and that might, there you go.
I would say yes. It may fall into the other category, and I should add to what was said earlier, that if someone wants to submit something that doesn't seem to be an ideal fit to topic C, 13C, for the two broad descriptions there, they can submit it under the other category, but make sure it's labeled as OLED so it gets routed to the right people.
Okay, very good. And okay, I don't believe I see any other questions coming through in regards to the topic managers that we have available for topic 13. If you do have questions for some of these other topics, subtopics here in 13, please contact for specifically subtopic A, Jacob Spendelow. You can reach him.
Yeah, and I didn't talk about that subtopic yet, so I was planning to do that still.
Okay, let's hear it.
Okay, great. Yeah, so this subtopic deals with development of new membrane materials for electrochemical devices, including polymer electrolyte membrane fuel cells and alkaline membrane fuel cells, as well as electrolyzers and photoelectrochemical cells. The membrane requirements for these applications have some similarities and also some differences. High conductivity and good mechanical strength are required for all of these applications. Good tolerance to RH cycling is important for fuel cell membranes, but it's less important for the other devices which tend to operate in a flooded configuration. All components of the membrane are of interest for the subtopic, including the membrane ionomer, support materials, and additives, such as additives to enhance performance or mechanical properties or durability. And we've got several questions about this subtopic, which I'll address. One of the questions was, of these three areas, of these three applications, which would be the fuel cells, electrolyzers, and PEC cells, which is DOE most interested in funding? The answer is we're equally interested in all of these. Selections will be made only on the basis of technical merit. We were also asked which kind of membrane would be favored, a acidic proton exchange membrane or an alkaline membrane. And again, we're not favoring either type of membrane. Applications for either one are welcome, and we'll just make the selection based on the technical merit of the proposals. Let's see, we had a question about whether applicants are eligible to submit proposals if they already have SBIR work funded in this area. That's probably a better question for the SBIR office. But speaking just for the subtopic, as long as there isn't already a project that's doing essentially the same thing. So in other words, as long as this proposal is distinctly different and doesn't overlap with an existing or a previous project, that's fine with us. We were asked whether flow batteries would be included in this topic, and the answer to that is no. We're only considering applications in the three areas mentioned, so fuel cells, electrolyzers, and PEC cells. There was also a question about cost analysis for PEC cells in particular, I think. And the question was about whether the cost analysis was supposed to cover components in the cell other than the membrane, and the answer is no. We're only looking at the membrane. And we were asked what sort of benchmark materials should be used for the comparison, and any widespread, commonly used commercial PFSA would be appropriate to use. And that's all that we have for the subtopic. Thank you.
Very good. And there are no other questions coming in for topic 13. So, gentlemen, thank you very much. I appreciate that. Let's go ahead and move on to the next subtopic, which is our second to last topic for the day. And this is topic 14, dealing with advanced fossil energy technology research. And I believe we have Doug Archer on the line here.
Yes, I would say last but not least, we're now into the fossil energy subtopic. And the topic 14 in general addresses grant applications for the development of innovative, cost-effective technologies for improving the efficiency and environmental performance of advanced large-scale industrial and utility fossil energy power generation and natural gas recovery systems. So we have basically four subtopics and then another topic. I'll address the first subtopic, and then I'm going to refer some of the other ones to some of the other topic managers that are online. The first topic covers shale gas conversion and to liquid fuels and chemicals. And specifically here, we're looking for proposals to develop novel and advanced concepts for conversion of shale gas to chemicals based on advanced catalysis. So that's the general topic description, and then there's a lot of references referred to in the FOA that kind of directs you to the type of catalyst and type of areas we're looking at. I had a couple of questions specific to 14A. One was, has the technology involved already been explored? And the purpose of this research is to develop processes for commercial application, ? Yes, it is to develop processes for commercial application, as are all SBIR projects. And this technology has been explored to some extent, and again, I refer you to the references as to what research, some of the research that's ongoing now, to give you some kind of reference there. The next question was in the subtopic shale gas to liquid fuels and chemicals conversion. Is there a lot of interest in methane? There is a lot of interest in methane. Is there interest also in upgrading natural gas liquids, ethane, propane, butane, pentane? And here, yes, there is interest also in upgrading natural gas liquids. I think that's mentioned in some of the either the description or in some of the references. For instance, if you can convert butane to butanol, that sort of conversion would also be considered applicable. For subtopic B, I'm going to refer that to Briggs White. I believe he's online to address that subtopic.
Okay, this is Briggs White here at NETL, DOE, and in subtopic B here, cost-effective interconnect coating process development, we're specifically looking for coatings in the seal area for solid oxide fuel cells. So these coatings would basically protect the stainless steel interconnects from the seal glass. There's already been a large body of work done to develop several different glasses, and there were a few references posted with the topic language. And the seal materials have shown to interact and form degradation byproducts when they're interfaced with the steels, as well as with coatings made of aluminum oxide. And so that research also showed that when interfaced with yttria-stabilized zirconia coatings, the seals didn't degrade. However, after doing some investigation with some of our partners within the program, we found that there really wasn't a commercially available process for depositing yttria-stabilized zirconia coatings onto stainless steel interconnects to protect those seal areas. So we're looking for some kind of a process that could cost-effectively put down that coating and do it in a thin, continuous coating, and that could ultimately be scaled up for mass manufacturing. So with that, I'll turn it over to Robin Ames, who's the TTM for subtopic C.
This is Robin Ames, also at NETL, Department of Energy. My topic, 14C, is discussing the development of enhanced durability, high-temperature coatings for utility-scale gas turbines, hot gas path components. So really what we're looking at here would be enhancing the durability of the coating systems. This can be either the bond coats or the thermal barrier coatings, meant to really allow the hot gas path components, either the first or second early stages in a utility scale gas turbine, to operate at temperatures above 2650 degrees Fahrenheit. Within the proposal language, we discuss a number of the critical things that these architectures must possess. I'll list a couple of them: sintering resistance, low thermal conductivity, etc. They're all listed in the proposal. There's also a couple references listed that you can check out, as well as some different ways to approach the research, combining the study of both metallic and ceramic components, and things of that nature. I also got some questions emailed to me, and I'll touch on some of them. There were a couple talking about the temperature range. I think I covered that in the language. Really, the goal temperature is 2,650 degrees Fahrenheit and above. There's also a question regarding specific composites and if they could be considered for the improved coatings. And while I can't comment specifically on, I don't have too much knowledge on the materials that they requested. However, really, we're not going to draw the line and say certain materials can or cannot be used. If they can be applied to the goals listed in the FOA, I think all would be considered. And then there's another talking about engineered surfaces to promote better TBC bonding. Would that be considered under this subtopic? I feel that that's likely slightly more applied than this is really looking for. We're looking for more of the actual coating specifics, and that would likely fall more under the topic 14E or other topic. I don't know if other questions have come in, but that's really all I have. I'll turn it back over for topic D.
Yes, okay. Actually, Joe Wong is the subtopic manager for 14D, but he asked me to field his questions. His topic is it's similar to the topic last year. It deals with high-efficiency heat transfer technologies for industrial and utility applications. And here we're looking to save on cooling water for power plants with systems like dry cooling systems that have more effective heat transfer surfaces and things like that. There's quite a few good references listed in this subtopic as well that you can kind of give you guidance. He had some specific questions. I think there's like 4 of those, which he gave me the answers to. One was, what are the operating requirements for the heat transfer devices envisioned in topic 14D? He stated that the applicant can perform literature search on the phrase ultra supercritical. He mentioned a textbook by Skrotzki, B et al., Power Station Engineering and Economy by McGraw-Hill, 1960, and he said other terminology can be searched, such as exit condition or synonym thereof. He asked, the next question was to clarify the evaluation review criteria related to the statement must show at least a 25% cost advantage using annualized levelized cost of electricity per megawatt hour relative to any commercial available dry cooling baseline. He stated that the base of the burden remains on the applicant to represent a persuasive and compelling case to one with ordinary state-of-the-art. He said established bases are preferable and can be cited with diligent research among the prior literatures of Bechtel, Sargent, and Lundy, and other numerous architect engineering firms that have designed or retrofitted power plant cooling systems. The next question was whether and how waste heat scavenging innovation fits into the topic area. He said that due to the quantity and grade of heat that needs to be dissipated, it would really depend on the capital expense and scalability of the applicant's scavenging innovation. And he said historically scavenging inventions have been limited by the capital expenditure, prohibitive costs, reliability, site-specific dependencies, and other footprint considerations. He said that you're advised to consider cost and footprint of implementing heat scavenging at a gigawatt scale. Next question was, our technologies was TRL1 of interest in advanced heat transfer, and he said that technology readiness level 1 technologies would be more appropriately directed to NSF or Office of Science solicitations. Then the next topic then would be E, which would be 14 other. And I generally would answer the other topic that would should fit proposals that are similar to the subtopics, but not specific, don't specifically fit into the subtopic. And that's what I would, kind of use as guidance for application. I had a few specific questions. To sustain economic growth, coal will be playing a role. Can a SITR Phase 1 proposal be submitted on coal for utilization in an innovative manner for steam electric power generation and industrial utility boilers? System will be equally applicable to current and second-generation lignocellulosic materials. Again, I would say the other proposals should be similar to the subtopics listed. This might be a little out of the scope of the subtopic. Again, another question similar. I'm considering proposing a hybrid piston turbine steam power cycle to improve thermodynamic conversion efficiency. Is that relevant? Again, it should be other proposals should be similar to the subtopics listed. Otherwise, we would get just a too large a volume of proposals outside the scope of what we're looking for. That would kind of finish subtopic 14. And I don't know if you want me to move on to 15.
I think we did get one question on 14C.
Oh, okay.
And the question was, can the research look at scale-up of these TBC coatings? We're looking to do the technology transfer and partner with the university.
This is Robin. You know, I'd have to see. I wouldn't be opposed to that as long as it's a novel coating that would enhance the durability like we're looking for. I don't think if someone's got a great idea out there that's a little bit more further along than just very basic research, I don't think we'd have a problem with that at all.
Okay, thanks.
Okay, so let's move on to our last topic of the day, topic 15. It's still in regards to fossil energies, advanced fossil energy separations and analysis research. I believe we'll kick off again with Doug Archer.
Yeah, topic 15 is similar to 14. Here we're kind of emphasizing the separations analysis aspects of fossil energy technologies. And here again, we're looking for larger scale applications for industrial and utility fossil power systems, CO2 sequestration, and natural gas recovery systems. The first topic, 15A, is also a repeat from last year, and it's looking for subsurface CO2 sequestration monitoring technologies. And that was Bill Fernald had actually received some questions there, and he referred those to me to answer. I think he has about 5 questions here. A couple of them I would refer to the SBIR office. They're in general, but the specific ones, I have one on is CO2 surface monitoring of sequestration sites of interest to DOE. The solicitation asks for subsurface monitoring technologies. Would surface monitoring be responsive? And the answer is yes, if it can help achieve the goal of decreasing the cost and decreasing the uncertainty in measurements needed to satisfy regulations for tracking the fate of subsurface CO2 and quantifying emissions from geologic reservoirs. The next question is size, weight, and power requirements. And Bill states that those are not specified in the topic. The next question is there a possibility for funding of advances in technology previously funded by SBIR? And his answer is yes. Another question is what range and resolution of CO2 concentrations would you like to measure for the carbon sequestration? How important is cost? And Bill's answer is a CO2 gas concentration as low as 200 parts per million should be detectable. Monitoring of CO2 above the reservoir should have an accuracy of greater than 99% and a precision of 1 part per million. The proposer should be able to define the problem based on literature from projects such as the Zero Emissions Research and Technology Center, or ZERT, project in Montana. And he referred people to the NETL website, www.netl.doe.gov, for references. And he said that the proposer should explain how the analyzer is novel compared to existing systems, and cost is an important consideration. Those are general. Their other questions can be referred to SBIR office. I think they're more program related or to the SBIR program. The next topic is subtopic is 15B, advanced shellgrass recovery. I don't know. Is Al Yost online to answer that? Okay, I was hoping Al might be available, but this is a new topic it's pretty self-explanatory. We're looking for technologies and measuring analysis devices to reduce the amount of water needed for hydraulic fracturing when you're putting in shale hydraulic fracture wells through shale formations. And I think he mentions some references there, and he specifically states the important areas that he's looking for are wellbore formation evaluation techniques, perforation selection strategies, fracturing fluid selection, and fracturing treatment design. And here again, he's trying to increase the efficiency of recovery on a per well basis and reduce the volume of fresh water required per unit volume of natural gas. So that, if you have any specific questions there, I would refer those again to Albert Yost at NETL. And then the last would be the other topic, and then here again, I encourage people that apply to the other topic to generally try to follow the subtopic areas, not to get too far away from those technology areas.
Well, hey, Doug, we have a few more minutes left, only a few left, and we have a few questions. Maybe you can take a shot at some of these, even though Albert Yost isn't online here. Maybe you can quickly address some of these. There's one question here on 15B and C, actually. Would improved downhole power production technologies that can enable better wellbore formation evaluation tools be acceptable?
Can you repeat that again?
Would improved downhole power production technologies that can enable better wellbore formation evaluation tools be acceptable? And if it doesn't make sense to you, maybe we should just have this individual contact Albert Yost directly.
Yeah, I would definitely contact Albert. That seems like it would be acceptable to me, but I would confirm that with him.
Okay, and this is for the other 15C other category subtopic. Would CO2 separation from flue gas by membrane separation be entertained under subtopic 15C?
Like I say, it should be similar to the existing subtopic. So I don't know. I don't think they mention that in the subtopics A or B.
Okay. Well, we can tell this individual as well if he wants to ask a more specific question, he can send that into to the topic 15 here, and we can look at it more closely and respond. And just a couple more here as time ticks down. Would solar blind detectors for operation in extreme environments fall within topic 14 or 15? I'm not sure I understand that either.
Well, that would probably fall under 15, but I'm not sure what that technology is. I'd have to look at it to see if it's really responsive.
Okay, and let's do two more questions here. Are you still interested in power plant mercury emissions monitoring? It says this was a topic under this topic last year, but it was not on the list this year.
Right, yeah, we didn't rerun that topic, and here again, I'd like to stay within the subtopic, generally within the subtopics listed if possible.
Right, and Manny, did you see any other questions there?
I guess there were a couple others. And so again, we are running over time, so I'd encourage you, if we didn't get your question today, if it's specifically related to the technical areas, to contact the folks that were listed. If it's a general question about the SBR, DOE SBR program, you could send that to our office. I'll just do one more here for you, Doug. Would fiber optic sensing be of interest for topic B or C? Or if that's something that Albert should address.
Yeah, you'd have to check with Albert. I would think both of those would be applicable.
Okay, so we'll end the questions here. So if you do have any additional questions, again, send them to our attention or to the program managers that were listed today. Again, reminder, there are 2 additional webinars this week for the remaining topics in this for this first release.
Yes, you can find the registration information for topics 16 through 28, which is tomorrow. You can find that, and for topics 29 through 40 on Wednesday. The registration links are online at the DOE SBIR website. You will be emailed a link with this webinar, this recorded webinar following shortly, sometime later today. You should be getting that of this webinar. And I would remind you that for your questions in regards to the funding opportunity announcement, that will be issued, as Manny had mentioned earlier, on August 12th, and there will be a webinar for that more than likely on August 16th. And if you have any questions, general questions, as Manny mentioned, you may also just call us at 301-903-5707. We can answer many of your SBIR program-related questions that way. And if it is in regards to the actual topics, go ahead and contact those managers directly via their email address in the topics document, which is also on our website and also included in the webinar here. Manny, would you like to say any closing words here before we hang up and wrap up here?
Yeah, again, thanks for everyone's interest. I know we did have, looks like almost a couple hundred people dial in today, so we appreciate you participating. And if you have any other suggestions to make these webinars more useful to you, please let us know.
Okay, well, thank you very much, and this concludes our webinar.
The purpose of that is to allow you to submit things that clearly fall within the topic. So again, at the top of this, beginning of topic 7 here, there's a broad description. It must fall within that broad description, but it might fall outside of the specific subtopics A and B here. And in the past few years, about I think 6 to 9% of our awards have gone through the other subtopic. And again, many but not all of our topics provide references. So these are provided by the program managers to help you bring you up to speed about what's going on in these fields. So we encourage you to take advantage of those. Next. One of the things we introduced last year were technology transfer opportunities, and we're going to continue that this year. These are really an opportunity for you to take advantage of intellectual property that was developed either at a DOE lab or university. And the intent here is different from our regular topics. In our regular topic, you are the program managers have identified a breakthrough that's required, and you're going to come up with an idea to address it. Here we've identifying, again, intellectual property, something that's usually been patented or has a patent application, and we're looking for you to take that invention and drive it towards commercialization. So not only do you get an SBR and STTR grant, you would also get an option to license the technology. There's more details of this in pages 1 to 2 of the topic document, so we encourage you to look at the very beginning of the topic document if you're planning to apply to a tech transfer opportunity. And again, these tech transfer opportunities will look a little different in the sense that you'll see much more information related to a national lab or a university. So we will provide you with contact information to a tech transfer office for research that might be of interest to you. What we do in our topics is list the DOE program managers associated with each topic and subtopic. You are allowed to ask them questions at webinars like today, but you can certainly email them between now and the time you submit your application. We do want to point out that their role is really to clarify what they're looking for, what the topic is about. It's really up to you to decide to apply. So you really shouldn't be asking them, should I apply or not? That's really your decision based on finding whether the technology and the expertise you have is a good fit to the problems they've identified in their topic. Next. Sorry, this is a little compressed on the right, but this is an example of the topic. So each of our topics, is numbered, and each of our subtopics has a letter. Those are very important, so you need to specify the topic and subtopic when you submit your letter of intent in your application. If you submit an application, for example, without a topic and subtopic, we won't try to assign it for you. You will just be administratively declined, so do pay attention to that. We have added a new header this year. It's a little box in blue up above, and that indicates the amount of the Phase 1 award and the Phase 2 award when you submit for Phase 2, and also indicates whether we're accepting both SBIR and STTR applications as well as fast track applications. So do read through that header for each of the topics you're thinking of applying to. As I mentioned before, we do list a program manager. They may vary by subtopic, so do make sure when you're asking questions that you pay attention to the fact that there may be multiple managers associated with a single topic. We do have another subtopic. Sometimes we get questions about that. Again, the purpose
to the Department of Energy's SBIR, STTR Fiscal Year 14 Phase 1 Release 1 Topics webinar. My name is Chris O'Gwin, and I will be moderating today's meeting. In just a moment, you'll hear directly from Manny Oliver, the director of the DOE's SBIR, STTR Programs Office. He will provide you with some basic topics information as it relates to this Release 1. Following Manny Oliver's introduction, you'll then hear directly from the subtopic managers, many of these subtopic managers for topics 1 through 15, as they clarify their expectations and answer your questions regarding their specific subtopics. And many of the questions received during the registration will be addressed as well. I will tell you up front, we've had with topics 7 and 9, that we will not be presenting those. So if you do have questions on topics 7 and 9, please email directly to those topic managers, as they will be identified on the slides as we go through that, or you can find the topics document on the DOE SBIR STTR website, and you will find that the address for that, the web link throughout the webinar. And a couple other things. Yes, you will receive a web link to this recorded webinar following the webinar. So if you're hearing me right now, that means you're registered, and all registered participants will receive that link directly from us following this webinar. It will also be available on our website as well. And I believe that's about it for the housekeeping. So let me go ahead and turn this on over to Manny Oliver as he gives you a brief introduction here to where we are. Thank you very much.
It's very similar to the schedule for last year. Just want to, for those of you new to the program, we do release the topics about a month before the funding opportunity announcement. We do have a letter of intent requirement, and that's a mandatory letter of intent. So please be aware of that. And again, there we're just looking for an abstract from your for your full application. For this Release 1, the applications will be due October 15th. And you can expect to hear from us in early January as to whether you were recommended for award, and your grant would start in February. Next. When we issue the funding opportunity announcement, we will hold a webinar later that week. The FOA will come out on Monday, and on Friday we'll have a webinar, and that's your opportunity to ask questions about, how do I apply? And questions more in the mechanics of the application. As I mentioned, today will be mostly focused on questions about our topic areas. And there will be plenty of opportunity for Q&A there as well. So in getting into the topics, the questions we get around the topics, where do we get our topics? So the topics are created by DOE program managers. They are often funding R&D, not only at small businesses through the SBIR program, but through universities and national labs. They're very up to speed on the activities in these areas. Many of them cover a fairly broad area, so they do rely on other experts, sometimes in the national labs and in industry and universities, to formulate where the breakthroughs needed to move some of these technologies forward. The other thing is, when we put out our topics, we do organize them by the program office. If you're new to DOE, probably over time you'll learn which program offices fund which types. Again, just the brief agenda, as Chris mentioned, I'll just give a 5-minute introduction. And again, today we're just introducing the topics. many of you might have questions about the number of awards and issues that would, questions we can address better when we put out the funding opportunity announcement, which will be occur in August. But today we're just really focused on the topics and your technical questions related to the topic areas. And again, we have 2 programs represented today in topics 1 through 15, the Office of Advanced Scientific Computing Research and the Office of Basic Energy Sciences. And we do have webinars on Tuesday and Wednesday for the remaining topics. Next. So for fiscal 2014, there are 2 Phase 1 announcements. We refer to them as releases. So Release 1, and here is the list of the programs participating in Release 1 and Release 2. And Release 2 will come out later in the year, about 3 months from now. So with Release 1, indicate these are going to be 5 of the programs from the Office of Science, as well as the Office of Defense Nuclear Nonproliferation. In Release 2, we will have many of the applied programs. One of the changes we made this year is that the Office of Fusion Energy Sciences, which last year participated in Release 1, has moved over to Release 2 this year. So please be aware of that for some of the folks who are expecting to see fusion energy topics in this release. There will not be any, but they will be in Release 2. Next slide. And again, here's our Phase 1 schedule for the year. And for both Release 1 and Release 2, there's not much that's changed.